Hello there. Let us look at C program lecture 3, wherein we'll look at a property of a number called strong number. So what is a strong number? A number is called a strong number if the sum of the factorial of its digits is equal to the number itself. What does it actually mean? For example, if I have a number 145, so 1 factorial plus 4 factorial plus 5 factorial should be equal to 145. So let us see if this is true. So 1 factorial is 1 plus 4 factorial is 4 into 3 plus in 4 into 3 into 2 into 1 plus 5 into 4 into 3 into 2 into 1, alright, which is equal to 1 plus, so you have 24, and this will be 120, which is equal to 145. So 145 becomes a strong number. Alright. So there are two parts to it. The first part is to find the factorial of a number. Of n. Then use the factorial of n to find strong number. So first we will do the first part, and then we look at the second part. Now, how to find the factorial of a number? The factorial of a given any number is, there are two approaches to this. One is n into n minus 2, n minus 1 into n minus 2, okay, dot unless you get 1. So that is one aspect. Second, 0 factorial is also 1, 1 factorial is also 1, and factorial is always for the positive numbers, right? So I see a pattern here. There are two patterns that I have. One is, the first pattern is, I can loop from, say, 1 to n and find the product, or use recursion wherein it exhibits a property wherein my fact will be equal to n into fact of n minus 1 till I reach anchor value of n is equal to 1. Alright, so we'll see both. So before that, first let me declare n. Okay, so let me have main. So I'll just accept the input, printf, enter n greater than or equal to 0 equals, we'll scanf percentage d and of n. We can put some conditions. If n is greater than or equal to 0, then we'll have two conditions. If n is equal to 0 or n is equal to 1, we will return 1. We will return 1. Okay, now when I do this, suddenly I use this function called return 1 for the main, so which is not possible. So we will hold this for some time, and then we'll simply type /n. The factorial of n is percentage d percentage d is percentage d so which is my n, and I'll call the fact function. Okay, so what is my fact function? So let me just define my fact function as a prototype. I'll say fact of int. So that's my prototype. So here I'll write a fact function which will say if int fact. Okay, here if n is equal to 0 or n is equal to 1, return 1. Okay, else I'll put a flower bracket. I'll have for I is equal to 0, I is equal to 1 to I less than or equal to n, I plus plus. Okay, so what will I do here? I'll say fact is equal to fact into I. Okay, once I finish the loop, I'll return fact. Okay, so I'm using this fact. Okay, so I will use a variable now called int factorial and I. Instead of fact, I'll say factorial. Now that is because the name of the function and name of identifier will be same. I can still do that. Nothing prevents me to do that, but that's not a good practice. Okay. So let us save this. So we are simply now looking at a strong number.c. We are not looking at anything else other than str number.c. Okay, so we will close it here. So we have declared n. So we are just first finding the factorial, the first part of it, before we find the strong number. So let me save this. Go back to my prompt. So gcc minus o op strnc.c dir star.c. So we have strn. Okay, all right. So we are getting an error. It says in function error expected before token. Okay, so we will put this in the bracket. Okay, then let's see if this is fine. Looks to be fine. op, so I'll give says 0, it returns 1. I give 1, it returns 1. When I give 5, it should return. Oh, so this is an error that we are getting. Let us go back and check why is this error we are getting. That is because I have not initialized. I'll initialize it to 1, otherwise it will be initialized to junk, because it's a local variable. All right, so then I will say 5. Oh, did I compiled it? No, now I have compiled it. So op5 is 120. I think we are getting perfectly fine, but I am supposed to find a strong number. Okay, we will see whether given n is a strong number or not. So for that, what I will do, I will take the number while, now this is not required for me because I am getting the factorial right, while I'll assign n to temp because I am supposed to get the individual digits. This logic we have already seen earlier. So temp is equal to n. We will say int temp Okay, we'll also have an int sum is equal to 0. So while my temp remains greater than 0, what I will do is I will take my sum. Okay, I am supposed to take this sum, right? So my sum will be equal to sum plus factorial of the digit, which is temp mod 10. Okay, each individual digit. Now I will say temp equal to temp div 10. So I am going to get the factorial of all the digits. I will put this here. I'll put a condition: if my sum is equal to n, then I will printf n is a strong number. Else n is not a strong number. Okay, let us hope that this logic works for us. Okay, so let us save this and then compile it. No error. So n is equal to, say, let me keep 145. So it is just giving 145 is some number, because I have not given sum here. Because n is equal to percentage d is equal to percentage d. I'll put here percentage d is not equal to percentage d, just to get the feel of that. So I'll give not equal to. So this will be my n, one more n, same, and put sum here, and this will be my n comma sum. Okay, so let us go back, recompile the code. So I'll give 145. So 145 is a strong number because 145 is equal to 145. Alright, because that 145 is my sum. Alright, now similarly, I don't know what all other numbers we have. So what we'll do is we'll generate n strong numbers. Let us see, do we have n strong numbers? So what we will do is we will say while my strong number count remain less than or equal to n. Okay, I may start from 0. Okay, my temp will be equal to, say, 1, and my strong number count will be equal to 0. Here I'll put a condition: I'll say my strong number count is equal to strong number count plus 1, else there is nothing. So here this while I'll take it out, and then in any case I'll do temp equal to temp plus 1. Okay, this looks to be fine. Okay. So my temp will be equal to 0. My temp gets divided. Okay, so I will have one more thing called say I, because I have to start from int I equal to say 1. So my temp will be equal to I think that should be fine, and my this thing will be I plus plus. We are trying to generate the first n strong numbers. Alright, let us see this code is going to work. Luckily no errors. So let me give, say I want 5 n numbers. Okay, so just going in an infinite loop. Let us see what the problem is. Now I have, while my SNC is less than or equal to n. Okay, so my temp is equal to I, while my temp remains greater than 0. Okay, temp div 10, so it comes outside of the loop. If my now sum is equal to n, then it is a strong number. I increment the count. Else it is not a strong number. I plus plus, my sum again has to be assigned to 0 because I am going to the next number. That may be the mistake. Sum is equal to 0. Let us see if we are able to avoid the infinite loop. So what we'll do is we'll just look at, I'm just doing the extempore so that you may also get the same error. So we have n is greater than 0, so you want first n numbers. So while my SNC, which is 0, remains less than or equal to n, my temp is equal to I, my I is equal to, I am taking the from 1. I am taking 1. So if my temp is greater than 0, my sum is equal to sum plus, say, fact of 1. Fact of 1 will be 1. So sum is equal to 1. My temp equal to 10 by 10. So it will come out here. If my sum is equal to, it is not n, it should be I. Alright, if my sum is equal to n, this will be my I and I. This will be my I and I. Okay, so I think then it should be okay. Then I'm incrementing, then I'm also incrementing the I. Okay, so let us go back. Hope some errors get eliminated now. So I give 3. Okay, so it is just searching. All right, so just to search for 3 numbers we are having an issue. All right, okay, so it's not an infinite loop, maybe it is taking a long time. So let us just change our output. I will only want one number. Let us see if we get any number. We just want one number. 1 is strong because, alright, so let us see if we get 2. Yeah, so my 145 is the next strongest number after 1 and 2. Alright, so let us go back and change this logic. We will do one thing. We will just take this and we will just display percentage %d comma, we'll just display I. Alright, otherwise we'll not display any message. Okay, so what we'll do is here, after everything is done, we will say printf the total number of strong numbers, total n strong numbers are percentage %d. Now NC we would have got, NC would have been greater than n, so it will be SNC minus 1. So that may be our numbers. So before that I will print here printf the first %d strong numbers are /n, this will be my n. Okay, so the strong numbers are, we'll keep it that way, so maybe we may get a better display. So let me go back and recompile the code. So we have 29.9 warning, so here n. Okay, so let me go back and try this OP. So I want only one number, so it shows strong numbers and 1 and 1. The total number of strong numbers are 8. Okay, that we will see. We will not. The total. Okay, I'm sorry. This should be. This changes. There are. A total of % is strong numbers. Okay, so I don't think there is any problem with the logic, maybe the output statement. So I will just do this and do the OP. So now I want only one number, only total one strong number, because we have only first one is 1. Now if I take 2, so it is 1, 1 and 1. If I do say 3, I'm just getting 1, 1 and 1. So here sum is equal to I, okay, so do I need an else here? Not required. Okay, so let me go back and do this. I need 1, okay, that's fine. So I need 2, so it is showing me 3. Okay, so that may be because of this fellow. Alright, so let me go back and do the recompile. I want one number, so there only one factorial is 1. I take two numbers because 1 and 2, 2 factorial is 2. I take the value of n to be 3, so 145. When I take the value of n to be 4, wow, so it is 40,585 is actually the strong number. So if I do n equal to 5, it's actually taking a so this is similar to our perfect number problem, isn't it? So it's the time complexity just increases. There are techniques probably we could try in our algorithms course later to reduce this time and at the same time get the output to be pretty fast. Hope that you are able to understand. I have not verified this. I think you please verify it in offline. If there is any issue, please mail me at nitinpujari@gmail.com. Hope you understood this video. Next programs in the next lecture. Thank you very much.